Very good afternoon. How are we doing today? Welcome on in, everybody. Welcome, welcome, welcome. Yeah, you need to stop harping on about it. Welcome on in, Winter Blue. Coming in with that first routine. Good to see you. How's it going, buddy? It is that time of the day, that time of the month, that time of the year, that time of whenever. The time when we break out the screwdrivers. And the rest of the technical equipment. We do the stuff, we do the things. Those of you here from Arena, of course, earning yourself some ARP while you're here as well. We're taking a look at the RTX5090 today. We've had the RTX5090 in our possession for a couple of weeks, maybe a little longer. Great looking little card, very solid. But as always, we want to find out what makes it tick and figure out what's going on inside under the covers. That is how our labs work. And so that is what we're going to do today. Dante, welcome on in. Good to see you. How you doing, buddy? What if Rob would like a safety tip? I will hold that thought until we switch scenes. But I will remember that you asked for one. You're tidying. So what you're saying is, I'm going to be making the mess by pulling things apart. But you're going to be tidying up the mess by putting things back together and putting them away. You're hired. You can come do the tidying in my workshop whilst I'm doing the dismantling. Well volunteered, Dante. Well volunteered indeed. And Hilarious, welcome on in. How you doing? You'll be there at some point in the future on an undisclosed date. Is that after the wife has authorised you to finish the tidying at your place and leave? Is that what it's kind of waiting on? Something like that. I thought it might be. Got a lurk? Well, you'll be pleased to know that while you're lurking, you're going to get your ARP at double speed today because we are featured on Arena. Big thanks to the Arena team for that. Yeah, no giveaway right now, but at some point soon, maybe. In fact, at some point soon, definitely. We have plans. We have big plans. But I'm afraid I can't give away a 5090. Much as I'd love to, I can't. What I can give away are some secrets. The safety tip? Yeah. Well, we're going to the workshop now, so you know how it goes. You know exactly how this goes now. I notched that down just a touch. And then if I push the right button and don't make a mess of it, because, you know. We have the workshop, we have the 5090. BL, welcome on in, buddy. Good to see you. How are you doing? Pushing all the buttons, yes. But all the correct buttons. And I'm now facing the opposite direction to the way I normally face when I'm streaming, which is slightly weird. But you know. Have a quick slurp of my mug of tea, and in fact that is our first safety tip of the night, of the afternoon. If you are going to have a mug of tea next to your workshop, which is not a terrible idea, having a mug of tea nearby so you can keep yourself hydrated, very useful. Do make sure it's on a different desk where you can't accidentally knock it and spill the tea all over whatever you're working on in the workshop. That is a very important safety tip. Got to be safe with your tea. It is a safe tea tip. We can't be having unsafe tea. And I know Oi Frog will appreciate that safe tea tip. Yeah, no worries, BL. Universal Studios. Ooh, very nice. Why did you not invite me? Why did you not invite me to join you at Universal Studios? You prefer coffee? Well, you can have a safe coffee tip then, which is equally similar. Don't spill your coffee all over whatever you're working on either. For the aforementioned same reason. Spilling one's drinks, hot or otherwise, on one's workbench is a terrible plan, and we don't want to see anybody doing any of that. We are going to move this camera down just a touch. Just like that. And this is the RTX5090 that came in my Area 51 desktop. Universal Studios is crazy overpriced. That's fair. You will note this is a very large card. Large enough that it just about fits in the camera frame. I may have to actuate the manual zoom, actually. Alternatively, I could probably switch lenses on the camera, but we kind of want the details, so we're going to stick with this one. It is very, very large. I mean, that is a pair of DJ hands, and the card is larger than a pair of DJ hands. That gives you some perspective. In fact, I'll tell you what. Let's be scientific and technical, because I know people like science and technology. So let's be scientific and technological. And let's break out the tape measure. Bring this over here. You can see the length of the card. You get a better angle if I do it like that. The card itself is almost exactly a foot long. The bracketry on the end, if we pop that up like that, this bracket here, another centimetre and a bit. If we look at it this way, we're talking 5.5 inches tall. Or if I get this on the back, let's flip the card over. And we include the slot. It is 6 inches tall, including the slot. And of course from the side, best way to show you this, it is a 3-slot wide card. This is not a small toy. Now, those of you who've been in my workshop before will know that, although a lot of people don't do it, we're going to break out the anti-static wristband. We use them here in the workshop. They're not strictly necessary, but they're recommended. Jimmy, welcome on in. I'm afraid you're not having the 5090. I'm afraid that's not happening, my friend. Much as it'd be fun, not happening. Keep wishing. So, we're going to take this thing apart. And to do that, we've got to figure out how to get into it. Now, there's a few screws on the end here, which will take off part of this retaining bracket. And I think we're going to need to get that out. There's a couple of screws this end as well, on the slot cover bracket. They'll probably need to come out as well. In fact, they will. There's a bunch of screws on this back plate. They too are going to need to come out. And then Lord knows what else we might find underneath here. Actually, the engineers know. When you set up a motherboard, is the anti-static bracelet necessary? Necessary, no, but recommended, yes. I don't know anybody who has blown up memory or anything like that recently. In the old days, it was a very common problem. But I always take the approach that it's better safe than sorry. You know, if there's a risk you'll do some damage to something, and you've got the ability to have a precaution like that wristband, which costs very little, and doesn't get in the way when you're doing it, then, honestly, save yourself the risk. You know what I mean? If there's a risk of some damage, then It's easier to just avoid it. Now, we are going to break out the screwdriver set. We're going to go straight for this handle, because this is the best of the three, in my opinion. We want to be using a decent screwdriver handle, very important. And I think we're probably using Phillips 1. So I'll take the Phillips 1 end of this screwdriver. I'll slot them together like that. That's the best way to do this. The guys on my Discord will have seen the photo earlier of the setup I'm working around. And can confirm there's quite a lot of stuff being worked around here. If you're not on my Discord, by the way, !Discord will get you the link to that. Right, that should give me a little bit more room to work. And you see, we've got those screws there. Now, they might be Phillips 1, they might be Phillips 2. So what I'm going to do is get the screwdriver. There's a little bit of movement on that. So I'll take the Phillips 2 end and just see if that fits these screws. If the Phillips 2 is too big... No, okay, so these on the end are Phillips 2. It will fit. And the biggest reason that people round off screws is by using the incorrect sized screwdriver. Hazel, welcome on in. How are you doing? We're about to start taking things apart, so you've come in at just the right time. We're going to start by taking this end bracket off. Now, I'm going to just do this on its side, because reasons. This is a ratchet screwdriver, but for things like these machine screws, is the middle fan more shiny? The blades go at a different angle, so the light will reflect off it differently. So it may or may not be more shiny, but the angle of the blades makes a difference. So we're going to start by taking off these screws for the bracket. Now, what I'm doing off camera is I'm creating a kind of tracking system. So I'm laying the screws out in the shape that they came out of the system. Not because I necessarily need to, because these are all the same, but just because it's good practice to do so. You can see the fourth screw comes out of here. Down the bottom there. And there is our fourth screw, which I'll put in that corner. So that's how I kind of track them. And then there's the bracket that's come off with it. So what I'm going to do is I'm going to move that off to the side. You see where the bracket is in the corner of the camera. I'm going to move it over there. Move the screws over with it so they don't get lost. Actually, what I'm going to do quickly is pop that over there. Okay, so we've taken off the end bracket. Now that's just a support bracket, you don't actually need it for the card to work. But in the Area 51, you get the beauty of it holding everything in there. Magnets can indeed prevent free-range screws, however, when I'm trying to track things properly, I like to track them in sections. And that's what I'm doing over there. I've got a small section with those 4 screws for the bracket. Now, I'm pretty sure these are not going to be Phillips 2s. I'm pretty sure they're Phillips 1. But again, we're just going to check. No, there's no way they're Phillips 2. Well, the beauty of this screwdriver is I can actually pop the entire screwdriver shaft out and grab the new one in a different size. So I'm just going to check, and just by hand, make sure it actually fits the screw very carefully. And it doesn't. Okay, that's not even Phillips 1. My big screwdriver kit doesn't go below Phillips 2. That's intentional. So what we do instead, because we're dealing with Phillips 0 now, This makes some horrible noise with the Velcro. And we break out the precision screwdrivers. Now I think I want Phillips 0, and you'll see these red ones here are labelled PH0, PH00, and PH000. 000 is the smallest, 0 is the largest. So I'm going to take the PH0 screwdriver. I'm going to see if that fits the screws. And literally all I'm doing is just pushing it up into the screw socket. And it does fit the screws, so we now know that the end screws here are Phillips 0. And if they don't want to turn to begin with, you don't just keep turning. What you do is you put more pressure towards the screw. Because if you keep turning, that's when you'll round them off. And that one had some thread lock on it. See the little blue gluey stuff? That is called thread lock, and what they do is they put a bit of that on the screw while it's still liquid. Literally a bit like glue. And then screw the screw into place. And then the thread lock will solidify like normal glue would. And it literally locks the threads into place. Do I apply fresh thread lock? No, I don't. I never bother because I'm not dealing with something like a car. Although with cars you'd use torque settings instead. And honestly, thread lock is only really useful for stopping things coming apart with vibration. Now, there's a lot of vibration in international shipping, so thread lock for that makes a lot of sense. There is not a lot of vibration in my workshop. So thread lock here would make a lot less sense. In fact, what I'm going to do is I'm going to try adjusting the camera just a bit. Bring that out that way. So, we've got the back plate of this card now. And there are a lot of screws on this back plate. There's also a little bit of dust on it because it's been sat on the bench for a week. So we'll just wipe some of that dust off. That's fine. Remember, of course, anti-static wristband means that anything like that that I do doesn't generate static charge. And you don't want to generate static charge because on the metal bits it'll be okay, but when you get on the circuit boards you're dealing with memory chips and things. And you really don't want to be messing with those. Now, these screws... These feel like they might be Phillips 1. They're a little bit wider. Yeah, okay. So the Phillips 1 bit fits in them. You read thread lock everything. You are one of those evil people. Okay. So we're going back to the big screwdriver, because Phillips 1 screws you should use a Phillips 1 driver with. I can't overstate how important it is to use the right size driver when you're dealing with screws. Not only because it makes it a lot easier to get the screws out, but also because if you don't use the right size screwdriver, you are going to damage things. Now again, you'll see there's a lot of screws on this back plate, and they're going to be in different places, so I'm going to basically build a tracking grid of the screws for the back plate. Again, up off the corner of the camera shot where you won't be able to see it too well. I might take photos of it and share them on Discord later for you or something. But we're just going to bring out each of these screws in turn. And I'm going to sort of build them into a picture of the graphics card on my desk. Now these are all machine screws, so they come out quite easily. But one of the reasons I also build these tracking grids is because not every screw will necessarily be the same length. Now if they've been helpful, all the screws for each section will be the same. But you can never guarantee that, because some screws might have to be longer than others, some screws might have to be a different physical size. And since you can't guarantee it, I always work on the assumption that every screw is going to be different, and therefore a tracking grid is a good idea. Now these screwdrivers are semi-magnetic. Has what been documented in the manual? Dismantling the graphics card? No. Alienware's manuals are fantastic for taking the whole PC apart. But this is not a unit that the customer would be expected to repair. You'd be expected to send the whole graphics card back and get it replaced. And therefore, Dell and Alienware don't provide a manual for taking the graphics card apart. There is no documentation or paperwork that will tell me how to do this. There's just my prior knowledge of how graphics cards generally come apart, my inquisitive nature, and a bag of screwdrivers. Again, these machine screws actually generally unscrew really easily. They don't always come out really easily, but they usually unscrew quite easily. So I'm building my little picture on the desk of the screws as they come out. And taking them out, you don't need to worry about taking them out in any particular order. Putting them back in again later, I'll show you the order I tend to use. But taking them apart, no need to worry about the order. You can see none of these really require much torque, so the screwdriver handle is a bit overkill, which is why I'm just using the middle of the shaft to grip them. It's easier that way. That one doesn't want to come out. There we go. Bit of a wiggle and it comes. So that's the screws on the backplate removed. And you can immediately see at this end that the backplate is loose, which is good. Over here, I'm expecting it to have some thermal pads or something underneath. And again, just touching this, the end brackets come off. Now that's really useful, because it tells me there's nothing sticking this end of the backplate down either. So I'm just going to pop that to the side with the two silver screws that came out of the end of it, so that I know which bits came from where. Now with stuff like this, where you've got thermal pads potentially holding things on, you don't want to just apply brute force, because we can't be sure that there's no other screws on the other side. We can be fairly confident, but again, it's all about looking at things and figuring out. So you can kind of see under there's some lighter bits. If we sort of look around here, you can see some lighter bits underneath there. They may be thermal pads. I'm not seeing anything that looks like a screw running through there. Submerge it in now. No, we don't submerge it in alcohol because we want to be able to reuse the pads. So what we're going to do is gently just lift the back plate bit by bit. And you can see it's starting to come loose. And there we go. It's lifted. And the reason it was a bit sticky was because of these rather epically thick thermal pads. Now, I wasn't anticipating them breaking today. That can happen with thermal pads, though, and it doesn't matter if they break. You can just reuse the thermal pad as long as you don't end up with the edges overlapping. Because that's the problem you'll have, is if the edge of the pad here overlaps with the edge of the other bit of pad there, where it's sort of ripped, you won't be able to get it to sit flat again. Do I have spares? Yes, possibly no, possibly maybe. I have spare thermal pads, however these are incredibly thick thermal pads. If you look there, that is way thicker than a normal thermal pad would be. So for me to figure out how thick they are, this is actually a great excuse to break out one of the tools that I don't get to use too often. Correct, my digital calipers. Which we know I don't use often because I don't actually leave the battery inside the calipers. Otherwise the battery goes flat. Can't use a micrometer, no.
I'm a mechanical man.
So, I'm just popping a battery into the calipers. So I've got some digital calipers here. These are a very good way of measuring a lot of things. And mine come in a fancy case that just keeps them all in one place and everything. So you always zero them at 0. Now, with these calipers, they measure the inside of this pair of jaws. They measure the outside of this pair of jaws. You see they'll slide. So if you want to measure how wide something is, you can go on with the calipers, but we're not interested in the width. Dagra, welcome on in. We're actually interested in the thickness of these pads, and there's 2 ways you can measure them. What I'm actually going to do is just peel the pad open a bit.
I'm a mechanical man.
And I'm using a bit of pad that's not been compacted too much. And I am going to just use this measure here. Now, it looks to me like that's going to be a 3mm pad. Yeah, it's about a 3mm pad. The other way you can measure it, and the thing people don't realise about calipers normally, is that on the other end of the caliper, as you move the caliper itself, there's a little spike that will come out. This is your depth measure. So if you want to know how deep something is inside of a hole, what we could do is we could line the caliper up on the end of the pad and use that bar to determine how far away from the board it comes. However, you can see we put a bit of a dent in the pad there. Retaining nuts. Actually, no, the retaining nut is not tight at all. It's the perfect tension. I'm just being fat-fingered. And it's actually also got this little handy dial, so I can move it more precisely. There's this little dial here which you can twist with one hand and it will adjust the calipers like that. But I reckon these are 3mm thick pads. Now, the 3mm is not a standard pad thickness. It's not a pad thickness that most people use, and it's not a pad thickness most people have. However, I may or may not. Let's have a look in the magic bag of cooling. Okay, I have 2mm pads. You can see they're 2mm thick. I don't think I have 3mm pads. I've got my laptop pads, which are 0.5mm, 1mm, and 1.5mm. But I believe 2 is the thickest pad I've bought separately. Yeah, so I don't have any 3mm pads. And that's fine, because under normal use you don't need them. And with this, we'll be okay without replacing the pad, because we can just make sure nothing overlaps. What you never, ever, ever do, under any circumstances, and I mean absolutely never, ever, ever do, is you never double up pads. Because if you try and put 2 pads, one on top of the other, you basically destroy any thermal conductivity the pad has at all. They're not massively conductive, but at the same time, putting 2 pads one on top of the other puts a layer of air in between them. That's a really terrible idea. You do not want that. That's the rest of the T finish off. Very important. So, we've got the back plate off. We discovered these thermal pads. I may order some 3mm pads later and replace them at another point in time. I don't expect it to make much difference on the back here, so I might not bother, but I'll do some testing. I'll determine whether it's causing a problem or not. If it is, then I'll replace them. If not, then I won't. But knowing how these cards go together, the next thing I think we probably want to do looking at this, is we just want to get straight in there We want to jump straight into the heart of this thing.
It's not good. It doesn't look good.
And again, I think we're working with Philips 1 here. Let's just check. Yep, the driver fits. You can feel when the driver slots into these holes. Now, this is a spring-loaded bracket. And it's spring-loaded intentionally
You need another shot.
to make sure you get the right tension on the heatsink holding it to the graphics card. And you can see as soon as that screw came out, that sprung up quite rapidly. So we're not going to mess around, we're going to undo the rest of these. Release some of that tension before anything goes ping, because we don't want things going ping. Things going ping is a bad idea. You can see now just how far up that's lifted, where the whole bracket is intentionally curved. And as this next one comes out, the bracket's going to go ping a bit more. I'm intentionally going slowly here. I'm intentionally taking my time about this. Because we're dealing with sprung, tensioned metal. And no, we don't use hammers. Hammers are a bad idea. In fact, I am going to put a bit of back pressure on that. So that's now loose, and this fourth screw will come out really easily. Like that. What we have now is our spring-loaded GPU retaining bracket. And when you look at it from the side, those bends are intentional. And we know it went on that way around, kind of an H shape. So I'm going to pop that to the side in that orientation, so that I know when I come to put it back in later, it's going to go back in the right orientation. Now, this is one of the funny things about these cards, and all modern day cards. This thing is a foot long. However, from here onwards, it's just cooling. It's just metal heatsink. The circuit board on this card is only this small area here. That is the magic circuit board. The rest of this card is a cooling platform. That's literally all it is. So we're going to be very careful. We're slowly going to try and sort of almost wiggle the card away from the cooling platform. Because I've had a quick look here and I can't see any more screw holes, and therefore there's nothing to screw this card in with. And that's good. This is always a slightly tense thing. I am just having a quick look off screen. As you can see where the connectors are there, there doesn't appear to be anything screwed in on that part. But I always like to have a quick look before I apply any kind of unusual or unreasonable force. You can see at the top here, obviously, we've got the fan and lighting power cables. So we're going to have to be careful about those. You can see up here we've got the 12 volt and 2x6 power connector, which everybody loves to hate at the moment. This one shows no signs of any melting or degradation at all. And it's been through some pretty heavy thermal testing. I've not been gaming on it much, but I've been doing high-end stress tests and things on it quite a bit. So we're just going to try and gently give this a wiggle. And it doesn't feel like it wants to come off, so I think we may have to explore further. Oh, that's one of my lights deciding to tell me that it's not happy, so let's turn that one off. It's probably not strictly necessary, the camera will figure it out without it, and I don't want it flashing at me. So whilst I can't see any extra screws or anything like that on this side, I am tempted to actually get in from the other side as well at this point. And when I say the other side, what I actually mean is there's screws on the edges here, which you can see there's 3 of them on the bottom of this top cover. Now these shouldn't be strictly necessary, Let's see, are they Philips 1s? They are not, okay. We go back to the Philips 0 driver. And again, we're just going to remove each screw in turn. I'm going to start a new grid over there off camera. And again, the most important thing is downward pressure. If your screw's not turning, don't use more twisting force. Use a bit more downward force. Because until you've got enough downward force to break the thread, break the what's the tension on the threads. And twisting is just going to make your life more and more difficult. 12 volt only makes perfect sense. Yeah, so I'm not talking about the 12 volt only. I'm talking about the 12 volt 2x6 graphics card connectors, which there's been a lot of concern about those cards or those connectors melting. And they had similar problems back on the 40 series with what they called 12 volt high power back then. I will say, as far as I'm aware, none of the Alienware cards had a problem with the 12 volt high power. Certainly my 4090 that I've been abusing for a couple of years. Well, that's exactly it. It started with the 40 series. That's when the issues started first. And they're using the same connections on the 50 series. Now, I'm going to lay this flat at this point, because without the end bracket, there's nothing really for me to stand on the desk.
Headshot.
Not that I'm going to stand on it, but nothing for me to stand the card on. And Varen, thank you so much for that follow. So, we're going to... going from the side to unscrew these. Again, I'm just putting back pressure on the heatsink to stop it skating across the desk. Forward pressure on the screw, and then unscrewing it. And then that screw pops out nicely. Goes into my tracking grid. Do the same in the middle here. They are indeed small screws, but they don't need to be big screws. Can you get a photo? Yes, as I said, once I've got all the screws and bits on the desk, I'll take a couple of photos and I'll share those on the Discord later, so if you want to be seeing those, you want to be on the Discord server. Exclamation Discord for those who aren't yet. So out comes the last of the screws on this top piece of shroud. Thank you, Blue. And then this top shroud is literally just lifting off. There's nothing holding it in place at all. What we do need to be careful about, and actually I'm going to turn the card around for this. Again, never be afraid to move things to make your life easier. You know, if you're pulling stuff in a direction that doesn't feel comfortable, stop and move it. So I can now just hinge that out of the way. Now, looking under there, there's some quite cool bits. You've got these massive screws holding the cables in place, or giving the cables, holding the cables into plastic brackets behind them. That's really smart, I like that. And what we can actually do at this point as well, and since we can see those connectors now for the fans, is we can very carefully unplug them. And again, I'm going to turn this round so I can get to them more easily. Now, with connectors like this, if at all possible, you don't grab the cable. If at all possible, you grab the plastic connectors. I can't get a proper grip on that yet, so I think what I'm going to do is actually leave it there for the moment, because there's metal bracketry in the way that's stopping me getting a grip on them. And pulling on the cables is a bad idea. It's the quickest way to destroy your cables or damage them. And so we don't want to be doing that. But what I'm doing here is I'm looking through the gaps that we can see to find out if there's any other screws holding that black mid plate down to the circuit board. And I don't think there are. You can see down there the lump and the shaft inside of it where the screw from the backside came through. But I think it's just the surface tension of the thermal paste and the pads and things like that that's holding this together. Need a JST tool. Yeah, that would be handy. However, I've not bought one. So I don't think there are any screws or anything holding this on. I think it's just going to be a case of give it a wiggle and hope that it comes off. But what we can do here... And Tahara, welcome on in. Is it Tahara? Something like that. Which power supply is compatible with this graphics card? So this is a 5090. Nominally, that means it's capable of drawing 600 watts. So any power supply that can supply 600 watts through the 12-volt 2x6 connector, which is that black power connector there, any supply that's capable of supplying 600 watts or more through that connector will be able to run this card. There are some caveats, of course, in that you don't want to be running on something that's only 600 watts. Partly because 600 watts is just for the GPU. There we go. A little bit of gentle wiggling, and off came this heatsink assembly in one go. So there was nothing else holding it on. Taking that fan piece off wasn't strictly necessary. But it was helpful. But what you got to remember, what I was saying to Hara, whilst the card itself can draw 600 watts, that is just the card. You've then got to remember the rest of your system around it, which is going to pull power as well. So now that we've got that heatsink off, there should be very little of anything holding this mid plate on. I can see a line of thermal pads under here, and a line of thermal pads over under here as well. So we do want to get those off. And again, the best way to do this is to just gently start squeezing things apart. There we go. Don't they draw less than what's recommended? Depends on what you're doing with them at the time. So again, I'm just putting a little bit of gentle pressure on the board, which I've got against the bench so I don't bend the board. Bending the board is a terrible idea. So I've got the mid plate out there, and you can now see those connectors are more accessible. So what I'm actually going to do is jiggle this around a bit so I can get to the connectors. Grab the plastic connectors themselves. And hopefully get the connectors to come out. That one doesn't want to. Just bear with me, I know you can't see this too well. These connectors are seriously stiff. That's one that's come out. That middle one came out quite easily in comparison. Okay, right. So that back plate is not attached to this bit, that can go over there. The mid plate is now off. We need to remember that those cables go through the mid plate. So when we come to put it all back together, I'm actually going to do it a slightly different order. I'm going to screw this back into that top piece and then put it all on as a single assembly. But again, you can see we've got a nice fat line of thermal pads over here and over here. And those are to contact between the top of this mid plate and the bottom of the heatsink. Take many photos or a video. So these pads are actually to link the top of this mid plate to the heatsink that's actively cooled. On this side, you've got some thermal pads here. You can see there's 4 places thermal pads would go there. There's one set of pads on there, and the other 3 sets of pads are here, here, and here. And they would line up with the pieces of metal here, here, and here. And then the other pads there, 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 and there are attached to our GPU video RAM, or video memory. And that's the biggest reason people buy 5090s, is not because of the... it's not because of the core performance, although that helps a lot, but the video RAM makes a huge difference. The more VRAM you've got, the higher resolution your textures can be, and the more you can load into video memory at once, which makes everything faster. What thermal paste have they used? So, I don't know for certain, but if it's anything like the paste they normally use on most of their other systems, it's going to be the equivalent performance to Arctic Silver. Not to be confused with the Arctic MX family. Arctic Silver is a completely different brand. I believe it's an equivalent performance to that. They certainly haven't used Element 31 on this. Element 31 is a hybrid liquid metal and paste combination, and they haven't used that on this, because I can see no blobs of liquid metal whatsoever anywhere. Which is good, because messing with Element 31 is something you do not want to do. And I've just realised I may need to be replacing these pads, because what I've noticed is where we were moving things around, the pad's folded over on itself. So I think I need to get myself some more pads ordered, because that is now not usable in its current form. Now I can put 2mm pads on there, but 2mm pads will not be thick enough and will not give you proper conductivity. And so putting 2mm pads on where a 3mm pad should be is a bad idea. Again, we are just going to double check with a piece of pad that's not been compressed or anything. But I'm pretty sure these are 3mm pads. Yeah, I'd say they're 3mm pads. I should be ordering some more 3mm pads. And I will figure out what I'm going to do about this separately. Once it gets that folded over and damaged, you don't want to be reusing it. That is not a suitable pad, as can be seen from the fact that you can't even lay it back flat again. So, well, absolutely, that's the next thing we're going to get onto. I do not use isopropyl alcohol, although a lot of people do. I actually use a proper product designed for the purpose, and we'll get to that in a minute. But what we're looking at right here, this is the magic of the RTX5090. Yeah, I'm going to replace all the pads together. But this is a 5090. This is all the 5090 is. Everything else on top of it is a cooling package. Everything else on top is a cooling package. So you could take a water block and put that on here right now, and that would be all you would need to do. Stick a water block on here, and this card would be the whole size of the card. Now, looking at this, what else am I going to be taking off? Yeah, we'll clean up the bits on the back there that don't look too good. We can probably get away with reusing the pads that were over here and over there.
Headshot.
And Sergio, thank you so much for that follow. Welcome on in. So I think it's only one strip of pad that I need to find a workaround for to get this back together and tested. Unfortunately, where those pads are, they're on the back of the VRAM, and that does need cooling because the VRAM will get hot otherwise, and you don't want that. I mean, it'll get hot anyway, but the hotter it gets, the lower your performance is going to be. But what I'm going to do before we continue messing with stuff is we're going to prep some of the rest of this and put it back together a bit. So we'll move the card out of the way and to the side. Move my heat gun to the side as well. And what I said we were going to do was put everything back together before we put it back on the card. So on the back of here, we've got one long thermal pad there and one short on the other side. And these pieces contact up against part of this heatsink. And so what you end up with, we'll sort of rebuild it on the desk bit by bit. So that would be on there. You can see that fits nicely on there. You got your cable access down here, and to get the cables from the fans through the heatsink into the card. That sits nicely on there, and that's not screwed in at all, but that's fine. It's just surface pressure. This whole assembly, and this is where it gets a little bit twiddly, this whole assembly sits inside here. I do mean inside. And so just reassembling this on the desk. And it's really important that these cables actually come through the holes in this mid plate. So you've got one that comes through there. My fingers are bigger than these slots. The screwdriver is not. The screwdriver can get those connectors through the slots quite easily. There we go. So I've got the cables all back through their routed slots. And what I'm actually going to do, you remember how we were unscrewing things from the sides here? I'm going to put this whole assembly back together, because we don't need to take that apart. What we've got there is absolutely fine as is. You see there's screw holes there, and literally all the screws do is they link between the outer piece and the middle piece. So I'm going to take our little screws, which are indeed very little, pop them on the end of the screwdriver, and just use a finger to sort of support the screw on the screwdriver a bit. This is the easiest way to get it lined up, because you're not going to drop it whilst you're holding it like that. You got a bail, no worries. And that will let you, because these screwdrivers are semi-magnetic. I mean, they are magnetic, but not hugely magnetic. So that'll get you as far as the hole. And then what I do is I always go backwards a couple of turns until it clicks. And then that tells me that I've got it seated in the thread properly. I'm only going loose with these at the moment. I'm not going super tight, because what I want to do is I want to make sure that the screws actually all line up properly. When you've got something machined like this, if you get one part slightly wonky, the whole thing will be slightly wonky, and you don't want that. And so again, just supporting the screw on the end of the driver. And over here you can kind of see that you've got to squeeze it a little bit to line everything up. So again, I just unscrew it backwards until I feel it click into place. And then I can just gently screw it back into the slot. Then we spin it round, we repeat the same thing again. And by doing it all loosely to begin with and then going and tightening it all up later, you don't end up with one loose screw that you forgot to tighten. Nope, that's bad on the view there. So you don't end up with a loose screw, because you don't want a loose screw anywhere. You don't end up with anything cross-threaded, hopefully. Because cross-threading things is terrible. If you cross-thread a screw, I'll learn to speak, that will ruin both potentially the screw and the threaded hole it's going into. The screw, not so much of a problem, you can get rid of that and replace it. If you ruin a thread in the hole, that becomes a whole different ball game. And fixing that becomes a bit of a nightmare. Gotta be careful about that stuff. There's our final screw from this part. And so again, just going backwards until I feel it click into place like that. And then just doing them loosely to begin with. So now all 6 are in. And what I can do is I can just go around and tweak them and just do a little bit of extra tightening. And it's only going to need about half a turn on each screw, maybe less. You can see I'm getting very little movement on the screwdriver. And that's because although I didn't do the screws up massively tightly, I gave them a little bit of tension to hold everything in place. There we go. So those screws are now suitably tight. They don't need to be tight enough to hold the world together. They do need to be tight enough that the card isn't going to come apart. So, what we're going to do next is we're going to start cleaning things. And this is where we bring in the legendary, only seen on this stream, or occasionally in person when I visit people, the Manky cloth. And this cloth is just used for removing great big clumps of thermal paste. Now, the paste on here... Oh, that's quite crispy, actually. Quite dry. Not sure that should be like that. I'd have expected it to make a mess of the desk already. I shall note that down for later. Don't worry, we're not reusing this paste, but the fact that it's a little bit dry like that and won't start wiping off immediately tells me we definitely need to break out the ArctiClean. Now, ArctiClean Bottle 1 is thermal material remover. This is not a game Kobe, no, this is us rebuilding an RTX5090 we've just taken apart. So I'm going to get some ArctiClean and just blob some on there. And then I'm going to leave that for a minute. Ah, but is it the real life, or is it just fantasy? And what I'm doing is I'm just letting the ArctiClean soak in a bit. And that's intentional, you just leave it for a few seconds. Listen to some music, enjoy yourself, relax for a moment. If you've still got a cup of tea, have a cup of tea. I haven't, I've finished my cup of tea, so I can't have a cup of tea. But if you've got one, have one at this point. You just let it soak in. And Salty has apparently spotted a squirrel somewhere, I'm not sure where. But if you let us know where you spotted that squirrel, that would be great. Because we like to know about squirrels and when they've been spotted and why. So that's had a little bit of time to soak in. We're going to grab the Manky cloth. And we're just going to start in a circular motion, wiping off the thermal paste. And you see great big lumps of that have come off there. And so I'm actually going to pull the lumps off of it and drop them straight in the workshop bin. Always have a workshop bin. That's really important. Don't just put a pile of mess all over the desk. This is why this is the Manky cloth. It's because we use this to remove the great big lumps of paste that start on there to begin with. And eventually what we want is we want all of this metal to be clean and silver. So I'm going to get a bit more Arcticlean, and I thought that might happen. That Arcticlean bottle is now dead. I get through this stuff fairly frequently, which is why I have more. Now, bottle 1 with the white lid is the cleaning fluid. This stuff. So again, I'm just going to generously put a load on there. And actually, while I'm doing this, because it's taking a bit of time to soak in, I'm also going to pop some on the center of the GPU core itself. We'll talk about this in more detail in a minute. But I'm going to put some on there just so that starts emulsifying some of that paste as well. Emulsifying is a great word, by the way. It's a brilliant word. And so I'm going to leave that to do a bit of emulsification. We're going to find a bit of the manky cloth that looks slightly less manky. And then again, we're just going to clean up some of that. And you know it's time to switch cloth when the manky cloth is making things more manky than it's cleaning. Then you break out the not so manky cloth. You find a bit of that that's less manky. You can see this is now taking off the leftover residue. Now it's interesting that there's some scratches on this heatsink, and some quite major scratches too. When we look at this whole area here where it's scuffed, that's clearly something that happened during manufacturing and assembly, because we didn't twist this in that direction at all. So it was interesting seeing that. And for those who don't realise, what I'm also doing is I'm making notes here for myself. And after I finish, I will reach out to the guys who made this card, and I'll let them know some of the things I found, because they love it when I do that. In fact, they might even watch the video. We'll find out. So, what you do is you run your cleaner in until it's fully clean. And then you break out bottle 2, which is the surface prep, or surface purifier. Now we want to purify this main area here. We also want a bit here, a bit here, a bit here, and a bit here. Because they're all important places where there's going to be contact with either thermal pads or with the heatsink itself. And again, we use the not so manky cloth on the with the surface prep, or the surface purifier. We find a bit that looks fairly non-manky. And we just sort of rub it or wipe it in. I tend to use a circular motion. I just want to get the surface prep stuff to make this surface as clean and as ready for the next contact with thermal materials as we possibly can. What you do not want to do at this point is you don't want to touch it. Now that won't do anything about the scratches. The scratches will be there forever. But at least what you can see now is that we've removed any muck and gunk that was on there. And that's really important. So I'm now going to move that assembly out of the way. Pop that over at the side. I'm going to bring the card back in, which has stuck itself to the desk with the thermal pads. You'll see now where we've left the Arcticlean emulsifying. It's all started going a bit runny and a bit manky. Which is perfect for the redeployment of the manky cloth. We want to try and get as much of this heatsink compound off in one go as we can. And this cloth is slightly absorbent as well, so using it to pick up what I can of the liquid as well as the paste. And that's why we use the manky one first, is to get rid of as much of the surface stuff as we can. Oi Frog, welcome back. I think you were looking for unlurk. So the less manky cloth comes in, yes, the manky cloth, very important. This is the not so manky cloth. And you don't need to clean this edge bit as well, but I tend to. Unlurk is an official command, as is lurk. So you will see there, that's now nice and shiny, and giving you reflections of my workbench. We're still going to use the prep liquid on it. And the bits around the edge of the die, so these bits at the top here where there's grey, they really aren't so important. Men with Twitch. Yeah, well, if it's here, it's important. So, you could get a toothbrush or something and go and pick out all the grey paste from in there. I am not going to, because it's not necessary, but you could. There we go, Wayfrog, and see Nightbot welcomes you back when you do that. What you don't do is you don't get a screwdriver and start picking inside there. Because all the little tiny silver dots that you see around the edge there are individual electronic components. And there's a whole bunch of them around the top. And you do not want to get a screwdriver in there and end up lifting those components out. No, I'm not going to show you why, Frog. So you can take a bit of cloth and you can try and pick some of the paste out with it. And you'll get a little bit. But you won't get all of it, and it's not necessary to get it out from around the sides there anyway. It's not going to make any difference at all to thermal performance. Now we want that bit to be nice and shiny. A safety tip recap. Well, the first safety tip was about your tea. Your tea does not go on the workbench. It goes out the way on a different bench where it can be stored safely and it won't end up getting spilt all over your graphics card. I'm going to pop some surface purifier on here. Just a little bit. Not a little bit more. We're not in the 90s, Oi Frog. And then we bring the cloth back in, and again, we're just going to rub the purifier into the die. And that's now super shiny and very clean. And that's ready to go back on. Now this is the next bit that's going to get a bit tricky. It's figuring out the way we want to do this. Because there's a couple of ways we could rebuild this. Obviously we've got this massive cooling assembly here. And what needs to happen is those three cables need to be plugged in here. Paste needs to go on there. The whole thing needs to be flipped over, and so it ends up on there. And then it all needs to be reassembled. So looking at this, we can just plug these straight back in here. We are going to have space to maneuver with that. So that's how I'm going to do it. Pushing on the plastic, not the wires. It's literally just a case of lining them up, pushing on the plastic until it clicks into place nicely. This is where we've got to be careful, because we're now dealing with fairly delicate connections, and this one doesn't have a lot of length on it. You do have a question, why does it look like many capacitors are missing? So, when they design circuit boards, they will design them for multiple products at once. And or they'll design them with multiple options for how to build the product. So they'll design the board once, and then they'll use it multiple times. But they won't necessarily need all the components every time. Now, I felt my hand knock against this back piece here, so what I'm going to do is I'm going to very carefully roll that up, pop that bit of thermal pad back in place. These pads are not wonderful. I have worked with much better pads. And because I felt my hand touch against this, I'm going to re-prep this piece. Again, just getting the purifier. And just to remove finger grease. Because it's really important that those pieces stay as clean as possible. And that will actually stand up quite nicely on its own there. We've got to be careful as well, obviously, that we don't pull too hard on these connectors, because don't want to go pulling wires out the back of the connector. That would cause a problem. So, now we bring in the thermal paste. Now I use Kingpin KPX. Partly because it's really cool and it looks pretty. It's a sort of teal, light blue colour, as you can kind of see. And all I'm going to do for this is I'm just going to use the syringe to put a nice thick line of it down one side. And I'll just wipe the end of that on the middle. That may not be enough, we may need more. We bring in our spreader. And a bit like putting icing on a cake, I'm just going to slowly spread this paste. Yeah, we're definitely going to want some more. What we want is a nice even layer across the whole of this die. We don't want any parts like that corner there where I spotted a bit that was missing. And again, because we're spreading it, we can be very generous with it. You just want a nice layer. And it doesn't matter if it's a bit thicker in the middle. Because what will happen with any that's left over is it will just get squeezed out anyway. So get as much of that into the middle as we can. There's a little bit left on the spatula, but that always happens. That'll go on the manky cloth and it'll be cleaned up later. And the lid goes back on the syringe, and that goes away for next time. You don't need bucket loads of thermal paste, but you need enough to make good contact. Now what I'm also going to do, just quickly while we're here, is just wipe off any surface dust and bits that have got on those contact places. And you'll see the thermal pads here, here, and here will line up with there, there, and that raised bit there. So they'll all line up nicely. And what we're going to do at this point is just going to carefully and gently roll this down into place. And you can't see too well from there, and I'll pick it up and show you in a minute. But there are indications on where it should be aligned. So now I'm going to pick the whole assembly up, and I'll show you what I mean. So you can see down there, there's some capacitors that run through holes in the mid-plate. For example, that one there, there's a hole around it from this metal plate. There's one over here that's the same. Now, they give you an idea of where you should line things up. And when you get it flipped over fully, you see with a bit of a gentle wiggle, everything sits down and flat. You can see all these screw holes line up nicely. And so if you look down through each of those places, you can see there's a thread marker. There isn't over there, and that's intentional. Because that is where your bracket sits. Over on that corner. So that's why that one doesn't have one. It's because this bracket will screw on like that. Or something like that, anyway.
No mercy.
Just checking, actually. That might go...
Mercy is for the weak.
I see the future.
No, it does all go on top, I think. Yep. So that will sit nicely on that corner when it's all done. Geeky, welcome on in. How are you doing? So we do know we need to replace some thermal pads. But the order we took this apart in is the reverse order that we put it back together in. So we want to bring this plate in, and this plate will sit nicely here. Now again, this one you've got to be really careful with, because there's a lot of tiny components in the middle of here. All of these tiny individual components. So you've got to be super careful when you're screwing this back into place. And with it being a spring-loaded bracket as well, what I'm going to do, again, I'm just going backwards to make sure I get the driver properly into the screw. And then backwards a little bit more to make sure it dropped into the screw hole properly. I'm only going to do maybe a full turn on there. And you can see this is a very springy bracket. It's intentionally spring-loaded. So what I now want to do is I want to do the opposite corner. And this is going to take quite a bit of pressure and force, because we're fighting the spring-loaded bracket, but that's intentional. So we've got to put the downward force on there. And you have to excuse me knocking the camera a bit there. This is a seriously springy bracket, so it's taking quite a bit of force to get this screw to start biting into its threads. Once this one's on, the other two will be easier. There we go. So, we've now got 2 of the 4 on. The other 2 are still going to be spring-loaded. We don't want to mess around or waste time on this bit. You want to get the next one down as quickly as possible. And what you do is you do it in an X shape. You always do the longest step you can first, to push torque in from the furthest corner away. Why am I taking apart the £2,000 toy? I'm putting the £2,000 toy back together. We've just taken it apart. You missed the taking apart part. You've returned in time for the putting back together part. I know, Frog, sorry to hear that. Yeah, she does need to be there, and Do look after her. So again, we're just putting a couple of turns in. Now, we're not screwing into the circuit board, because if we were, that board would probably crack by now. We're screwing into the metal heatsink below, so it's all very safe. But now that we've got it in place, and the spring-loaded bracket started to sit flat, what we can do is we can start going a couple of turns at a time. I'm going to do an extra turn here, because that was our locating screw, so it wasn't screwed in as far to start with. So I'm doing 4 half turns or 2 full turns. And you'll notice I'm doing it in an X shape. And that's just to keep everything flat and even. And the reason you want to keep it flat and even is so that you don't end up with uneven pressure on the graphics card die from the heatsink. The whole point of these spring-loaded brackets is to keep the torque and the tension correct. Now, as I said, I do know I need to buy some more thermal pads. Okay, so that's bottomed out. And I felt that start to slip. This is where using the correct size screwdriver is important, because you don't want to keep twisting when it starts to slip, you want to stop. And with a small screwdriver in a larger hole, it will slip more than it should do and it will damage the screw. So they are now all tightened up. This whole assembly is now back together. But you can't just use it like this. As we said on this back plate, this pad, which has got a slight rip on the end of it, is fine because the other half of it's over there. That pad there will contact this surface here, so that's fine. This pad will contact these components. But this one, where the pad basically died and fell apart that I need to buy a new pad for, goes on the back of these components. And this is all video memory. This is all really important stuff. You need it to be kept cool. What I am temporarily going to do is I'm temporarily going to put the 2mm pad that I've got here in there, even though I'm fairly certain it's supposed to be a 3mm pad. Because I don't have anything thicker, and right now I want to get it put back together and tested. You should not do this, and you should not do it long term. But we have some 2mm pads. So what I'm going to do is I'm going to take the pads off of all of it. I'm going to try putting 2mm pads on there instead. We'll see if they make contact properly. If they do, then it just tells me that these might be a slightly different type of pad. Because again, pad thickness and pad compression are two different things. You can have really thin pads that have no compression at all, or you can have really thick ones that squish and compress a lot. So I'm actually going to peel these pads off. Now again, these are a bit solid and a little bit crusty almost, so we're just going to pop these off bit by bit. You see there's quite a bit of residue being left behind. But that's okay, because again, and I'm just going to lift these off here as well. Again, our Arctic Clean is designed for removing pads as well as paste. One pile of thermal pads, which are now of no use to us. Now you can also buy thermal putty, which you could use instead. And some people love it, some people hate it. Personally, I've never used thermal putty, and I don't think I ever will. But you can get thermal putty if you really want to. And some people think it's better than pads. But it also makes a heck of a mess, and if you try and take it apart, Why am I wearing a bracelet? Ah, we covered that at the beginning. Oh, hang on, hang on, hang on. Hang on. I have some even thicker pads I'd forgotten I got in that bag. Let's see if these measure with our calipers. That's 3mm. If they do, I don't need to order any new pads. Now bring our calipers back in and zero them out.
Headshot.
I have indeed got 3mm pads. A novel fun, welcome on in. I do not need to order new pads. I have some 3mm pad. Excellent. I thought somewhere that I did, but I wasn't sure. I have, so we're good. And why am I wearing a bracelet? So that was the other safety tip that we covered earlier. This thing is an electrostatic discharge protection bracelet, or wristband. What it does is it makes an electrical connection with my arm, and then this cable hanging off the end of it, which my camera's just decided it's going to freeze and die on me, bear with me. Bear with me while I give that a quick kick. Always the way when you're trying to engineer something. Let me push that button quickly. And let me push that button again. And we're back. So, the wristband has a cable attached to it. And this cable runs all the way off to my anti-static work mat. And the work mat keeps this whole surface anti-static, this matting you see down here. This is a protective surface, but it's also an earthed surface. And the idea is I don't build up static electricity in myself moving around and then end up getting that static electricity to discharge itself through things like the memory chips, which would be really bad. As I said, in the old days, you had to be really worried about destroying them. Modern day, not quite so much of a problem, but you still want to be careful with it. But in the old days, it was absolutely a big problem. So you kind of watch out for that. So again, what I'm going to do is I'm going to get the thermal material remover. See, it says it removes thermal compounds and pads. Keep away from children. Sorry, Oi Frog, you're not allowed any. So what I'm going to do is I'm just going to dot some onto these bits of thermal pad residue. I say dot, it's more of a healthy helping that I'm putting on there. And again, that will just start to emulsify those pads a little bit, which will help me to remove them. There's not really much on here, but it doesn't hurt to do a quick dot around all of it and just clean everything up a little bit. That doesn't hurt at all. So again, we just let that soak in a bit. I'm actually going to start with this piece, because this piece has got very little pad on it. And so again, we're just going to use the manky cloth to begin with. You can see it's leaving a bit of thermal paste residue, so we'll remove that as well. With the less manky cloth. We want this to be nice and clean. And when the manky cloth gets too manky, the manky cloth will be got rid of completely. The less manky cloth will become the new manky cloth. And the brand new clean cloth in the bag will become the less manky cloth. We have a hierarchy of manky cloths. Now I'll move that to the side for the moment. Bring this in. And we've got to be really careful with this, because again, whilst we're trying to remove all the thermal pad bits, we don't want to pull any of these components off the board. And I'm actually not sure this cloth is going to do a very good job of this. It's catching on a lot of the raised components. And so instead what I'm going to do is step away for just one moment. Bear with me. I'm going to grab something else. And what I have grabbed is, as those from my electronic streams will know, my electronic cleaning toothbrush, which is actually an electrical toothbrush. Do not use it for your teeth. I use it for, well, use a normal toothbrush for your teeth, but this one I use for electronic stuff, which is why it's got a load of discoloration all over it, because I've been using it on things like flux and solder and so on. And all we're going to do is just get the brush in there, because the bristles are soft enough that they won't be ripping up any of the components. And that's why the Arc to Clean is such a good thing. Because you can see it's loosened up all of those thermal pads. To the point where the pads come off. And again, I'm going to get a bit more Arc to Clean down on here. The pads come off, the components don't. That's why you want sort of soft bristles like a toothbrush. And then the manky cloth to remove some of the excess liquid. This looks really horrible, but it's okay. And again, thermal pads are not as sort of sensitive as thermal paste is. But you've got to be really careful with this. Even these specialized cleaning cloths. Case, welcome on in. Even these specialized cleaning cloths will rip apart if they catch on the metal components and the metal solder joints. Now, none of this is electrically conductive, so we're okay on that front. But again, all we're doing is removing as much of the old pad residue as we possibly can. Now, you could take this off and give it a bath in isopropyl or something like that, and that would work. But it's also not critical for thermal pads. All we're interested in is getting the lumps out from here. It looks awful. And Savas, welcome back. Good to see you again. We do have some giveaways coming up in some future streams, so do keep coming back. We have some planned. Right now, as I said, trying to just remove as much of the surface residue as we can. And that honestly should be adequate for that area. Now I'm going to put some of the prep liquid on here as well. Which you'll see has immediately pushed a bunch more of the pad away. And then we're just going to pop that on there. It's on the title description. Yeah, it's always in the title description, don't worry. Unfortunately, I can't give away a 5090. Much as I would love to give away a 5090, I can't. It's always in the description, because the command is always there. And you're always welcome to run it, just to see if there's a giveaway going on. So that side there will be fine as is. I'm going to bring the brush back in. I'm going to take off these bits of pad here. And this is why stuff like Arctic Clean is great. Now, the bit that I do want to keep absolutely shining clean is this connection down the bottom here. Because that's the bit that goes into your motherboard. And you do not want a bad connection on that. The rest of this is soldered, so you won't get a bad connection. But this piece down the bottom here absolutely wants to be kept completely clean on both sides. How big is a 5090? Well, we measured it at the start of the stream. We will measure it again once it's put back together. And then I will show you. We got the tape measure out and everything. Not messing around here. Once again, a bit of prep liquid on there. And just a bit of a clean off. Now we've got these ones which, again, lots of bits of pad that were left behind. And you can see, from what was a solid pad, the Arctic Clean's basically turned it into a goopy liquid. Why would anyone take apart their GPU? Ah, there's a number of good reasons to do that. You wouldn't do it with a brand new one. Unless you mean. I would. To teach you guys how to do it. But you guys would not take apart a brand new GPU. However, after you've been using your card for a couple of years, the thermal paste inside it is going to get a little bit solidified. Especially with heat cycles and so on. It's going to get a bit manky. Not quite as manky as the manky cloth. That's got the monopoly on being manky. But it's going to get a bit manky. And at that point, the cooling system is not going to be cooling particularly well. And if you've got an older graphics card, then you start seeing weird random crashes and things like that. And stuff that's just not working the way it should do. It's entirely possible it's just overheated. And I'm going to use the brush again to remove any bits of cloth that have got ripped up. This is the problem with working on non-flat surfaces like the areas where the components are, is that they will pull bits of the cloth out. So you've got to be really careful with this. Now I might wash this board down later with isopropyl. I might not. It probably doesn't need it. Because this is just where the pads go. So yeah, what you would do is you do what I've done here, which is you'd take the heatsink off completely, you'd clean everything up. If the pads were broken, you'd remove the pads, you'd get some new ones as well. Again, I'm just using some of the surface purifier here. And the idea would be that if you give it a good clean, and while you're there, remove any dust and mank that's got into the heatsink as well, because that's a common thing to have to deal with. You don't want any dusty, manky stuff in your heatsink. Give it all a good clean, put it back together. You'll probably find it runs a bit cooler. And with graphics cards, heat is the enemy of performance. It's the same with processors, actually, as well, but especially with graphics cards.
Headshot.
And PMKY, thank you so much for that follow. Welcome on in. Should you be planning to clean your graphics card? Most of the time, it's probably acceptable to just get some compressed air and spray it through the fins on the heatsink. Get any dust out of the fins. So, like, if you look on this one, for example, there's a massive chunk of metal fin stack here. There's another massive chunk of fin stack there. This fin stack runs all the way down the board. And when that gets full of dust, and in your case, cat hair, that will stop airflow. You'll also probably want to clean the fans as well. And what you can usually do is take the outer shroud, this black piece here, off, as I was able to do with this. And the fans either come out with it, in the case of this one, or sometimes the fans get left behind and you take them out separately. But you may absolutely want to strip it down at some point just so you can clean out any dust and muck from inside the fins. And that's a really important thing to do if you start seeing performance problems that you can't explain, or your graphics card's crashing a bit, or things aren't running as well as they used to, and it's been 3 or 4 years, or whatever it may be, you know. You don't have to do it all immediately, but it's worth bearing in mind that that could potentially be a cause for some weird behaviors. And again, this looks really messy and horrible, but that's because the cleaner I'm using is designed to basically liquefy the pads. And it's doing a very good job of exactly that. Again, all I'm doing here is just dabbing against the board, because there's so many tiny components that if you start rubbing too much like this, you'll leave bits of cloth behind, or you'll potentially rip a component off the board, and ripping a component off the board would be the worst thing you could possibly do right now. Zyberin dusted his after 5 months, it was colossally clogged. Yes. If you have animals, like Case does, I know Case has got a very cute cat, who occasionally we see photos of on my Discord. We need more photos of the cat. We need more photos of all the animals, but especially cats. But yeah, cleaning your graphics card, getting any dust and mank out of the fin stacks especially, is going to help a lot. Because what you don't want is for your card to be overheating and thermal throttling. And actually, the bit I'm dealing with now, this area is as important as the main die, because these areas are the back of the video RAM chips. And your video RAM chips are the memory that your graphics card uses to load up things like all the textures that it needs to display. So if you're in a game with a lot of textures, the more video RAM you've got, the better. Especially if you're trying to play it in 4K or something like that, where you've got really high resolution, very large texture files to load. Now this may look like I'm being quite rough, but I'm actually putting a really light amount of pressure on there. Partly because I keep skagging the cloth. You see, that was a perfectly flat cloth until it kept getting caught on all the solder joints.
Headshot.
And Kusaru, thank you so much for the follow. Welcome on in. So I'm just going to do another layer of the prep liquid. Is that why I said 8 gig is enough? In 2025, nobody should be selling graphics cards with 8 gigs of VRAM. There are many games now which start requiring more than that to run properly. In fact, some games require more than that to run at all. Yes, Case did get a new case. I may have made that joke yesterday when I was informed. So with Case, this is now the case. Case was indeed on the case for a new case. That is how it worked, Toyfrog. Well done. 8 gigs. Yeah, exactly. The 5060, the Radeon 9060 XT, both have an 8 gig version. Neither of them should have an 8 gig version. In 2025, there's no excuse for it. No excuse at all. So what I'm going to do now is I'm just going to lay this on here. So I know I need to be cutting roughly there. Now you can use a knife for this. Honestly, I'm just going to use scissors. It works just as well. And these thermal pads have plastic on both sides. If your pads don't have plastic on both sides, you're going to have a more difficult time. So I only actually need 2/3 of that. And so I put that on there. I can cut it at that point there. And actually what I'm going to do is I'm going to measure it again against this side, which is where it's going to be in contact. Yeah, so right in the middle of that indent is where I can cut it. So I can cut it right about here. That bit of pad is now spare, I can use for something else. So, what we do is we take the plastic off like that. It's just a standard plastic peel. Pop it down on the board where it needs to be, making sure it doesn't overlap with the bracket here, because if you get your pad overlapping with the edge of this metal bracket, the edge of the pad will never sit flat. Riri, welcome on in. How you doing? So you want to get that nice and flat. Now, I'm not sure that's quite aligned properly. Let's just tweak it a little bit more. And again, it's, as you can see, where I've got to try and make sure it doesn't do that and overlap the pad, or overlap the bracket next to it. So I get that nice and flat, and I'm going to leave the plastic on there now. I'm going to take that off at the end. Now, measuring this up, that's now about the right length. But if I cut it there, then I can't do any longer strips in future. Actually, I know what we do. Why not align it on the external bracket? Because I know where it needs to sit on this side, and if I do it on the external bracket, Kusaru has apparently spotted a squirrel somewhere. Do let us know where. We do love a good squirrel sighting around here. If you line it up on the external bracket and it's wider than the bracket and you don't quite get it right, then you'll end up overlapping on... I shouldn't be using scissors to point this. You'll end up overlapping on the edges of this piece. And if it's overlapping on the edges of this piece, it will never sit flat on the board. You've got to negotiate this raised piece. There's no raised pieces on the back bracket. So making sure you don't overlap the back bracket is more important. Now I want to cut it about there-ish, I think. Which, yeah, measures up to be about the same as the other one anyway. And so again, we're just going straight across with the scissors. Nothing special. You all know how to use scissors, hopefully. You saw another squirrel in the garden last night. Very nice. And then because we know these pads are the same size, we can use the bit we chopped off the other one as our measuring piece, and we can double check that to say, yeah, if I cut that where the other one was cut as well, and just using that as a measuring piece. We now have another pad that should be the same size. No running with the scissors. Oi Frog's only allowed the plastic safety scissors, yes. And again, we're just going to take the plastic off one side of this pad. It doesn't matter which side goes on the board, because both sides have got to be thermally conductive, otherwise it's not going to work very well anyway. And again, you can see over here, this bit's overlapping. So I just need to adjust it slightly, so that it sits down flatter there. And these will get squished a bit when we screw the backplate back on. Yeah, they're 3mm thick pads. Very few things actually use 3mm pads, but these do. Now, we actually want the width of that for this piece. So again, what I can do is I can just use the other pieces to measure the height, I think. Yep, that should work. So I'm just chopping the pad to the right size. Where's the heat going to go? The back plate is metal. I'll show you in more detail. And so again, we just slot that pad into place there quite nicely. And then when we turn the card around, we can get to the last bit. Now, those two will actually fit that gap nicely. And then we don't end up wasting things. I will actually leave a slight gap in the middle, because actually the two chips are at the edges. And that middle piece is not strictly necessary. So I'm going to leave a slight gap in the middle. Because you can see, when you look here at this sort of cross-shaped thing, that's the memory chip that we're cooling the back of. And so we can just slot that into place like that. A third of the card is fins. Yes, absolutely. And most of the thickness of the card is fins. And again, we can just slot this one into place there. And there's a little gap in the middle, but that's not the end of the world. So now that we've got all of these pads in place, and we just double check none of them are overlapping the edges of the support bracket, before we do anything else, we need to remove all the plastic peel. And you'll notice that started lifting the pad a bit, so I'm going to use the plastic, if I can, just to push the pad back down a bit and make sure it's lined up. I'll also use the screwdriver to give it a gentle tweak. Because again, what we don't want is for these pads to be overlapping. We don't want them overlapping the edge of the bracket, otherwise they won't squish down properly. I'm trying to avoid getting my fingers on them, because finger grease is not a good conductor. And so again, we're just carefully removing all the plastics. That's actually a common cause of overheating, is when you put new pads on and forget to remove the plastics. And you don't want to do that. I'm also trying not to lift upwards, because the more upwards you lift, the more likely you are to pull the pad out from where you've just put it. So you'll see I'm kind of going sideways on it. And stabilising the end a bit with the screwdriver there. And then we've got one more over here. So that's all the pads replaced with new ones. No, this is not paste at all. Thermal pads are a very different material. They do a very similar job, but they are a very different material. Now, what I need to double check here is this piece. This will go on the end. It'll go on the end down there. And that's really important because that's what holds your card into your case at one end. But if I remember correctly, this came out before the backplate came off. So we're going to grab our backplate now. And this backplate is all metal. What you've got on the inside here, the bit that looks kind of carbony, this stuff, is actually just shiny plastic. And the reason that that's in there and glued on is to stop you accidentally shorting any of these metal joints on the back of your backplate. It's an insulating layer to protect the card from the backplate. That's literally all it's there for. So we're going to flip this back over. I'm going to carefully line it up, and that's immediately caught on a pad. Give it a bit of a jiggle into place. You can see right away that this is now going to start pushing those pads down, and as we screw it all into place, it's going to make contact with the pads. Is this a soundtrack from the new game? No, these are the soundtracks from the original Command & Conquer and the original Command & Conquer Red Alert. So, your backplate's on there. And what we need to do is remember to slide these bits underneath the edge of the backplate before we screw it on fully. In fact, what I'm going to do at this point, now that the pads are protected, is I'm going to take my two screws that are on the end of this plate, which I believe we said were Phillips 0. Yep. And we're going to screw these back in. Again, we go loosely to begin with. And I usually go backwards first. That last one I knew would dropped in straight away. You go loosely to begin with. All you're doing is lining it up, holding it in place. We will tighten those once everything else is back together. So we got our card. And I forgot to take a photo of the tracking grids that everyone wanted to see. But what I'll show you is over there, this pile of screws. You'll notice there's the same sort of pattern with the two sticking out the end as the two that stick out the end here and here. And you got your top one there, which goes to there. And then the rest of them are in parallel pairs. And that's why they're in parallel pairs on the desk. Yeah, so I always do half a turn backwards and to make sure the screw locks into the slot. And you'll feel it click into place when it does. I'm also going to start at this corner. And so I'll drop that screw into the socket there. Now these, we said, were Phillips 1. So break out the big screwdriver again. And I'll go half a turn backwards on it until I feel it click. Okay, Okay, it's not clicking, which tells me that something might be misaligned slightly. There we go. There's the click. And then we can just go straight in. Now, again, I'm not going to go tight. I'm going to leave it fairly loose. And that's intentional. So we go backwards until the click, which I heard there. You won't have heard it, but it will have clicked. Then you can see there's a lot of movement on this because those pads are quite thick. And again, that's why we don't go tight to begin with on the screws. Because if you tighten everything up and something's misaligned, your last screws won't go in at all. Whereas if there's a bit of play on all the screws...
Y'all son of a bitch.
Thermal pads are on the heatsinks for M.2 drives, yes. They are less thermally conductive than paste. But they're better than air. Air is a terrible conductor of heat.
Y'all son of a bitch.
I'm just moving this so I can get to
I saw you what you did when you dropped your soap the other day.
everything a bit better.
Just do it up. It's more like a Isn't that what it is at the end? Great future.
We're actually going to skip this one. Because we don't need the outtakes.
Left, honey.
Just...
Got to make sure we like the music. Can't be having any outtakes and things like that. And so yeah, your M.2 drives, they will have thermal pads on their heatsinks. So again, backwards until it clicks. Then a few turns in, it's still loose, intentionally. And pads are there to be better than air as a thermal conductivity medium, but cheaper and easier to work with. Okay, there was the clicks on that one. Now these on the end have to line up through multiple bits, including the bracket, which is, again, why we didn't want anything else to be super tight first. Because those end connectors are spring-loaded, and you can see as I push that the bit of metal inside here is moving. As is the whole of the outer piece. Again, this is why you do things loosely first. So what will happen is when I put that in to begin with, it won't drop down until I push on the bracket. Then I'll go backwards until I feel it click. Back there. And then you can start feeling it pulling everything together bit by bit. Is it okay with a bit of the thermal pad bent up in the corner? Yes. As we tighten the screws down, it's going to compress everything together. You didn't want tons of it sticking out the top. So again, I'm going to do this next piece, which is slightly spring-loaded here. And just make sure it's all in place. I felt the click nicely on that one. You can see that's just spinning without any pressure at all. Which is exactly what you want. If you can get it to spin without pressure, the machine screw is going into the machined slot nicely. And again, with this one, bit of a back turn. There we go. I felt that click immediately. And with all of that done, what we can do is we can start doing the screws up. And what I'm going to do here is I'm actually going to sort of do a diagonal pattern. And so I'm going to do this one, then that one, then that one down there, then this one up here, then the bottom one here, then that one there, then we jump to this one, down to that one, then finally up to the corner there. And the reason for doing that is because we want everything to be nice and evenly torqued and as flat as you can possibly make it. And my screwdriver is slightly too tall, so I'm having to work around my camera equipment, which is all hanging from above. So that's that one that we said we were going to start with. Then we said we're going to jump to this one here. And again, you don't force it. If it feels like it's stopping, if you keep forcing it, that's when you will round out your screw. And rounding out your screw means that the screw is useless, but also sometimes means it's very hard to remove the screw again. Now the backward turn trick, unless somebody's told you about it, you will never realise. It's not something to feel dumb about. Those of us who've done a lot of engineering and things, we kind of forget that not everybody has done anywhere near as much as we have, and not everybody knows what we know about what we're doing. Which is kind of why I love doing these streams. Because you guys get to see something that you may not be comfortable with. You don't do the back turn once they're already threaded. Once you've threaded it in part way, you don't need a back turn. It's literally just to get it to go in the first time. And it's usually only about half a turn, and you'll feel it click or drop into place. Because when you think about a screw thread, and I'll try and show you this in a minute once I finish getting this back plate back on. When you think about a screw thread, what you'll realise is that it's only got one point where it will latch into the thing it's connected to. And that'll make a lot more sense when I show you. Okay, good. They're all on, and they're in. And as I said, we didn't do these end screws tightly because we wanted everything to line up. So we bring in the correct screwdriver for the job. Don't be tempted to just grab what you've got handy because it might work. And then we'll just nip these up a little bit tighter. Get that bracket fully on. Oh, Frog does the backwards thing on bottles and jars. Yeah, so here is a screw. If the camera will let you see a screw. That is a screw. It's a very hard one to see this with. Have I got a better screw to demonstrate with? Yes, yes I have. Perfect. Here is another screw. And this is actually perfect, because this is what we call a self-tapper, which is why it's spiky and pointy on the end. And you can see there is only one spiky pointy bit. And as we turn, you get to the edge of it. And the camera is having all kinds of fun with the focus, because reasons. So, what you're looking for is the edge of the round threaded part. Not the point at the end, because the point on a self-tapper is there just to make the hole to begin with. But the edge of this threaded piece, the beginning of the spiral, that's the bit that needs to fit into essentially a slot in the screw socket. So what you need to do is you need to line up the slot with that piece. Now, most of the time when you put your screw on or put your screw down into the hole to begin with, it's not going to catch that. But if you go backwards, it will lift out of the socket until it hits the edge of that piece that it's trying to lock into. And then you'll feel it drop into the hole a bit further as it goes past the edge and drops into the place where it's going to lock into. Is any of this making any sense to anyone? Or have I confused a lot of you? It makes sense. Good. So basically you go backwards until it drops into place and you feel that click and the little drop. And then you know it's lined up and you can start screwing it straight in. And you won't have problems with it not being in the hole properly, because that is a problem. If it's not lined up in the hole properly, it won't screw in very well. Now, there's one thing we need to reattach on this card, which is this phenomenally over-engineered, in the best way possible, GPU support bracket. I'm going to take a quick look at this, because it sits on the end of the graphics card like that. At the top, you have 4 spikes. And in the Area 51 case, the GPU bracket has 4 holes that these spikes slot into. So it locks into the whole of this bracket. You also have 2 little studs on the bottom there, which also lock into slots on the GPU support bracket. So this is screwed to the end of the graphics card with 4 screws. And then this locks into the bracket in the case with another 6 points. 4 spikes, and these 2 T-shaped nubbins, for want of a better word. And then just to make sure, just in case that lot wasn't enough, just to make sure it doesn't go anywhere, they put a screw hole in the top that you then screw the bracket into as well. Just to make sure. You know, because 4 spikes plus 2 nubbins weren't going to be enough to make sure it stayed still, right? Have to have a screw in there as well. That is what's called engineering. And the reason it's engineered like that is because these things have got to get all the way around the world in the hands of the global courier system. And we know how careful they love to be with your packages. What's that? Handle with care? Okay, let's play football with it at least 3 times before it gets to you. Sounds about right? Yeah? That what we're hearing? Because that's what I'm hearing. So what we do is we do exactly the same thing again. Now, I've changed the screwdriver blade. This is now the Phillips 2 blade. Because we know from when we started, these are bigger screws, and therefore they need a bigger screwdriver. Don't be tempted to use a Phillips 1 driver in a Phillips 2 screw, because it will slip and it will round off. And again, I'm just going to line it up there. I'm going to go backwards. And there we go. I felt the click. That one wasn't a very loud click, but I felt it. The package will be dropped at least 3 times in transit. At least. And again, I'm leaving that loose enough that we can do that. Because if I do that really tight now, I could tighten that up, and this would be on the wonk, and we wouldn't get any of the other screws in the holes. And you do not want things to be on the wonk. Like soda bottles there, cap's attached to the bottle, you can't remove the cap fully for recycling purposes, but it makes it harder to screw the cap back. Yes. Yes. Messes with the alignment, it's always crooked, you can't quite get it back. I have the same thing every time I grab something like a Coca-Cola bottle or something like that, and I'm trying to lock it up afterwards. Getting it to click back into place on the top is a nightmare. And Case, you've probably come across that as well without realising it. So again, I'm going to go with the diagonals. I felt the click really quickly on that one. But again, we're going loose to begin with. And whilst it doesn't really matter the order we screw these into, it's force of habit now for me to do diagonals. And again, none of these are going in tightly to begin with. None of them are going in tightly. That clicked really quickly, which is nice. Now, this is a ratchet screwdriver, so I don't have to keep changing my grip, I can just keep turning the back of the handle. You see how the middle bit, and therefore the end, only turns in one direction. For things like this, where I've got to use one hand, Limitless, welcome on in. Where I've got to use one hand on this because I'm steadying the card with the other. Being able to twist it, and then turn my hand back the other way, which you can't quite see there, without having to move it, makes life a bit easier. This one down here is not going to have the back torque yet. So we'll twist it a few times in the correct direction. Now we've got back torque on it. And it just means that I can steady the card on the desk. Normally I wouldn't be worried about the camera, I'd be holding everything a little bit closer. But I'm doing this for you guys' benefit. And then we get the last one here. Just tighten that up. So, we've now got our support bracket on the end, locked in place, with our screw hole at the top for the GPU support bracket in the case to screw into. Got our excessive amounts of cooling fins. Got our fans, and that one's a little bit manky on the front now because it's been on the workbench. So we'll just use a not so dirty cloth, or not so manky cloth, to remove bits from there. Got our GPU fans, which look awesome on camera. And yes, the middle ones are shinier plastic than the outer ones. Down at the bottom here, got all your metal fins. You may notice the odd occasional fin that's not quite lined up perfectly. That doesn't matter. As long as the air can get through between them, that's all that really matters with that. Again, back to the top there. So you can see, for example, this end fin looks like it's slightly bent inwards. We could spend all day trying to bend that outwards, and in fact, my fancy screwdriver kit has a specialised tool for that kind of behaviour. Almost like a miniature crowbar, which you can sort of just get in there, give it a bit of a tweak, but we've got to be careful. We don't want to pull it too far. Get it nice and straight like that, but it's not strictly necessary. You don't have to do that. You can leave them with, like over here, that one's been slightly pressed in as well. It's not the end of the world. I'm going to push it out just because we can, but you don't have to. And then on the back of this card, it's got another massive set of fin stacks. And everything's lined up. We've got new thermal pads in there, which this backplate will be pressing down on. Got our power connectors, all three of them. One of those connectors has extra pins on it to power this white light that says GeForce RTX. Federal Ghosts, welcome on in. Good to see you, buddy. It's going well. We've just finished putting back together an RTX5090 that we've been taking apart for the last 2 hours. How are you, buddy? It's good to see you here. This thing is my newest shiny that needs to be played with and taken apart and put back together. And we have just been playing with it, taking it apart and putting it back together. And now I need to remember, because my workbench has a lot of stuff on it that's been moved, because we've been working, and when you work you move things around to make your life easier. That's what I put down. Bigger than your 3080 Ti. Well, let us deploy the tape measure. This card is literally a foot long, plus the bracket on the outside. If we measure it without the slot, it's 5 3/8 inches tall. If we flip it over so we can include the length of the slot as well, I would say that is 5 15/16 inches, including the slot. Or for those of us in more sensible measurements, 151 millimeters. And that is 304 millimeters in length. As for thickness, this is a 3-slot card. So it's just over 2¼ inches. It is, I'm going to call that 58mm. Tape measures are your worst enemy for reasons. Which reasons? And then, of course, on the end of it case, we've also got this extra bracket, which I wasn't including in the length measurement. And that adds... I'm going to call that an extra 15mm. Incidentally, little known thing that a lot of people don't realise. You see how the bit on the end of my tape measure is wobbly? That is the case on all good tape measures. You can see that metal moving there. You can see it moving in the rivets. And the reason that the end of it has to be wobbly, I have PG-13 is history and very PG-13. This is a little known... Well, it's known by engineers, but not by non-engineers. The reason that the end of this always moves, and the reason you should allow it to move, is because when you look at the end of the metal, that metal is a certain thickness. So the reason it moves is so that when you hook something on the inside of it, your measurement graduations are the correct length. But when you push it up against something, it moves the metal plate inwards enough to make sure that you're measuring including the thickness of the plate and still getting accurate measurements. So this is an engineering thing. It's supposed to happen. It's a designed engineering thing. Having a wobbly end is the correct way for your end to be on your tape measure. Your tape measure end should always be wobbly. If your tape measure end isn't wobbly, you haven't got a very good tape measure. So there we have it, the RTX5090 taken apart and rebuilt. Uses one of these 12-volt 2x6 power connectors. I have not seen the one on my 4090 melt at all. I don't anticipate the one on the 5090 will melt either. But that's because I know that the power supply it's connected to, the cabling it's connected to, and everything else are all designed to avoid that kind of thing, because they're aware that it could be a risk, and therefore they've engineered it to avoid it. Funnily enough, that was one of the questions I asked when I first found out about this particular card, was what have they done to make sure that won't happen? And the answer is, over-engineered it. Your 3080 Ti uses 3 8-pins? Yes, that's totally normal and totally sensible. A card like this, which is capable of drawing 600 watts, on a connector that's only rated, I think, for 610, 650 watts maximum, you haven't got a lot of margin for error. I would be a lot more comfortable if these had 2 of these 12-volt connectors, but in NVIDIA's infinite wisdom, they said, no, we're only going to use 1. And that's fine, as long as everything works perfectly the way it would do in a lab. But this is not the stream for us to rant about this. This is the stream where we've just finished putting this back together. J Prime, thank you so much for that follow. Welcome on in. We finished putting this back together. I'm going to go put this in the Area 51 desktop again in a minute. Sake, welcome on in. We're going to go put this back in the desktop PC. We're going to play some games on it later. We're going to see how this 5090 performs in the kind of games that I play, which are a bit of everything, really. But there you go, 5090 taken apart, rebuilt, cleaned up, new pads put on, new paste put on in 2.5 hours. And with that, what I'm going to do is I am going to head over to here. I'm going to pull that down, just like that. Going to hit that button, and that button as well, and that one, and then this button. And those are the buttons we press to do the things we need to do. And pain in the assessment for wiring. I love that. I love that. I'm going to use that in future. It's a pain in the assessment. As always, massive thanks to everyone who's been here today. Everyone who's lurked, everyone who's chatted. Everyone who's followed for the first time. You're all awesome people. We really appreciate each and every single one of you. We are going to go and check out another member of the Alienware Nexus. A very good friend of ours. She's lovely, you're going to love her. She has a fuzzy cat sat next to her desk on a floating platform attached to the desk. So we're going to go see a bit of the cat and the cat cam. Yes, we're going to go see Hazel. We've had a bit of a blast doing this. It's been fun. The workshop is back with a vengeance. You love the fluffy cat. Everybody loves the fluffy cats. So make sure you grab some emotes because we are going to go see what she's up to. As always, a massive thanks to all of you who have been here. Let's get that raid going out. If you're not on my Discord, you should be, and there is a handy link. Make sure you come and hang out there. Our normal schedule is up for change, so I'm not going to throw the schedule into chat right now, but we are updating it potentially soon. And so we're going to find out how that goes. Tanak didn't start with the back screw on bottles until he saw my advice about screws. Yeah, something like that. And yeah, I'll see you guys in Discord. I'll see you guys elsewhere all the time, all the place, all the stuff. Do the usual things, but grab those emotes. Let's go throw some of those in Hazel's direction. Let's go make some noise over there. Let's go say hello to her, see how her Saturday is going. She's just chatting at the moment. I think she'll probably get into some games soon. Don't know about you guys, but I've had a good time taking that card apart. But all that's left for me to say now is thanks for hanging out. Stay safe and stay in touch. I'll see you on Hazel's stream, and I will, as always, see you on the next one.